Hello, and welcome to Ayers Associates' presentation on post-disaster mapping projects. This seems an appropriate time to talk about post-disaster mapping. There are fires in the west, hurricanes in the south, all sorts of disasters around the country and around the world. A mapping program that is well thought out and well planned and well executed can assist in both the assessment and recovery after all sorts of disasters. First, a little bit about Ayers Associates. We have to have the commercial here. My name is Craig Gooding. I am a business development specialist in the geospatial division with Ayers. Ayers is a national engineering and geospatial company with headquarters in Wisconsin and 12 offices around the United States. With me is Tyler Kabish. Tyler is a project manager in the geospatial division and with a particular focus on local government work. You see here listed a number of different disciplines and divisions within Ayers. In the projects that I talk about, there will quite often be participation from these other disciplines within the projects. So natural disasters can have immediate and long-term effects, and those effects can be financial, they can be effects on individuals and their lives, they can be on the communities and the relationships. One key point about all the projects I'm going to talk about is that there was a mapping project in place prior to our project that I'm going to talk about. Where aerial imagery, possibly LiDAR, was being collected on an ongoing basis over a period of time to support transportation, economic development, planning, utilities, and so forth. It was also useful for unplanned events such as natural disasters, as I will describe. The first project I'm going to talk about is a post-tornado regrowth assessment for Menominee County, Wisconsin. I love this picture. It's fairly easy to tell where the tornado path was. A little bit about Menominee County. It is the newest county in Wisconsin. It was formed in 1959. Before that time, it was the Menominee Reservation. Businesses within the county are managed by Menominee Tribal Enterprises. They are known as a world leader in innovative forestry practices, have people visiting them all the time to see what they do to manage their forest lands. In fact, forest products is the largest revenue source for the tribe. Therefore, a 21 square mile area of downed trees is a big deal. They wanted to get on top of it as quickly as they can, figure out how to make that part of the forest come back and start producing revenue again as quickly as possible. Because of the long time frame, they wanted to get after it as soon as they could. They brought us in after 10 years to get a sense of what the forest was doing up to that point in time. But they needed to know, they needed to find out what info could they get and how could they get it to minimize this long-term economic impact. They didn't have the money to do a full boots on the ground assessment. They didn't have the time. It was going to take years, literally, to inventory on the ground a 21 square mile area. And there are concerns with safety because even 10 years on, there was plenty of downed timber and other dangerous hazards. So here's an example. This is 10 years along after the tornado, and you've got saplings that are, basically head high, just stuffed in there shoulder to shoulder, as it were. How many are there? How on earth can you find that out? What species are they? Are they ones that we want? Are they ones that they don't want? How do we figure out what we've got and what to do with it? How do I even plan and execute a program to determine what I've got out there? It's 13 miles long, hard to get at. Roads are kind of scarce. It's swampy. There's standing water, lots of down trees. The vegetation is all different kinds. There's really no way to figure out how to do this, certainly in a comprehensive asset fashion. They had access to Landsat imagery, but the resolution wasn't sufficient to support looking at individual trees. However, the county was fortunate in that they had been a part of an aerial imagery program in that part of Wisconsin for a number of years that was managed by Ayers, and still is for that matter. So they had a good baseline of data going back for a period of time that they could use to show the before situation and see what they wanted to get back to. So 10 years on, the data that we were using, it was very fortunate that we had just flown imagery and LiDAR in the spring before they approached us for this 10-year assessment. After that, using that as our baseline, then we went out and did a leaf-off imagery collection the following fall. The next spring, we did another imagery collection for specifically to identify pin cherries. Pin cherries are non-commercial trees, a pioneer species. The easiest way to identify them is to wait until they're blooming in the spring. So that's what we did. They were very easy to pick out. We also did oblique imagery, and that imagery was primarily used for context and for quality control. And then finally, we did have some surveyors go out on the ground, collect some data, GPS some information, where we identified verification information for specific trees that were used for training and for quality control. So then it came time, once we had all this data collected, to bring it back into the office and start to break it down. Usually when you are segmenting imagery, you'll group pixels of like spectral signature together to create an object. In this particular case, the pixels more or less were the object. Most of the trees were no more than a pixel or two in size. Therefore, what we did was we made each pixel into an object in its own right and matched it to regions of pixels with similar imagery. And then we defined the shape and the size and the signature of that to identify the species of different trees. From there, we went to identify meaningful objects across the landscape that represent the species of interest to our client. So that sample data that we had pulled together from the imagery was used to classify all the pixels across the 21 square mile area. A trained image analyst supervised that process to verify the objects were correct, the classification was correct from all of these sample sites on both sets of imagery. We identified hardwoods. We also identified dead trees, water, and open ground. So here's an example of what we came away with. On the left is one of the images that we collected. This is in the springtime, the pin cherries, and you can see, you know, a lot of the foliage, or excuse me, the blossoms that are out. So the pink on the right-hand side is all the pin cherries that were identified. Green is hardwoods, gray is dead trees, and then yellow is aspens. Identifying the dead versus the commercial versus the non-commercial gave the tribal enterprises the info they needed to develop site-specific plans. So what were they able to do with this data once we got it all pulled together? They were able to match out naturally regenerating stands that were doing what they wanted them to do, basically. So they could go out there, examine the situation, see maybe if there was anything they could do to thin out some of the pioneer species that they didn't want, and so forth. Look at areas that weren't coming back the way they wanted them to. They need to go out and plant. They need to do any other sort of management efforts, and then manage the pioneer species, which typically are the ones that do not have a lot of commercial value, and kind of encourage the important tree species to come along and eventually take over from these pioneer species. The benefits that they got out of it, obviously they overcame the fact that they did not have the staff to go out in the field and collect this information. By doing it through aerial imagery, we were able to take it back into the office and perform the work that way. Saved all the money that they would have had to spend doing a boots on the ground, very labor intensive prospect. Doing all the time that they didn't have, they were able to get out in front of the process much sooner, and therefore they will realize the financial benefit on the back end. And obviously the safety consideration, they didn't have to send their people, or for that matter a consultant's people, out into the field to do an on-the-ground assessment, and therefore people were safer and obviously a lot happier. The next project that I want to talk about is in Ashland County, Wisconsin, which is in northern Wisconsin. In 2016, there was a major flooding event. There were a total of 200 washouts all across a couple of counties in this area. It's a heavy on Lake Superior, so there's a lot of tourism. And unfortunately, this happened at the height of summer, so it really massively affected the tourism and the economy of the area. We Ayers have an emergency engineering contract with the Wisconsin DOT. Therefore, they reached out to us to get things up and running as quickly as possible and get these roadways restored to the best of our ability. So we in mapping worked with our structure engineers, our highway engineers, and our hydrology water engineers to put this together. They wanted the designs fast-tracked. They wanted them back within 2 weeks so that they could start the process. The main reason they needed them within 2 weeks was that they had a deadline that they needed to submit estimates to FEMA in order to get funding. So we put together a process, which I will describe, for how we were able to turn this around so quickly. The good news is that just like the previous project and the next one, there was already existing aerial data in place. We had flown within the previous year or two both LiDAR and imagery for this area. So we once again had a good baseline, which was, as you'll see in a moment, was critically important to be able to turn this around quickly. The first, I'm going to talk about 3 different bridges or culverts in this particular project. The first one is County Highway E over the Marengo River, or in this particular case, it's the other way around, under the Marengo River. This culvert had washed out 3 times over a period of about 5 years. Therefore, they had decided it was probably time to do something a little bit different. We were able to have our surveyors on site within 2 days after the flood event, and we were able to do the change analysis from the previously collected aerial LiDAR data within a day after that. So in 3 days, we had determined what the changes were to the landscape in this particular case. So the LiDAR was used to estimate the materials, the elevations, how long the area was that had been washed out, how much was gone, how much needed to go back, and so forth. In every case, WISCOT wanted us to analyze 3 different alternatives. One to replace things exactly as they were, one for a larger culvert, and then one to replace the whole system with a span bridge. As I mentioned, the LiDAR had been done 2 years previously. The imagery had been done the previous year. So we had a very good baseline to work off of to determine which one of these we might recommend, but to give them, in any case, all of those alternatives. So we've got, this is not much of a creek. So this is an awful lot of damage for not much of a creek. Silver Creek really made a heck of a mess of this roadway. Basically a 25 to 30 foot washout. You'll see later on that it was determined, rightfully so, I think, that replacing it as it was not the right decision. One of the things that was an issue was the Bad River tribe was completely cut off on their reservation from the outside world by this particular flood. And that was in the case for 4 months until all the roadways were restored. They literally had to have people airlifted out of the reservation for doctor's appointments, medical treatments, and so forth. So this was very critical for the lives and health of the community as a whole. So Silver Creek, which is the pictures that we were just looking at, was a single box culvert. Roadway was washed out. Unfortunately for WSDOT, it was already planned to be replaced, and they were 50% of the way through planning and engineering the replacement. Well, that all got ripped up and started over. But fortunately, we were able to do that quickly. As I mentioned, we were out there within a couple of days. We had the plans turned around in 16 days and back to the contractors who were going to perform the work. The roadway as a whole was open within less than 4 months from the event. Trout Brook is the third bridge that I'm going to discuss, or third culvert. You can get a sense of the size of this thing. The surveyor is standing down there next to the washout. His scanner is up there by the roadway, and that is the process that we use. We use stationary scanning for all of these. So this was a double box culvert, so it was built to carry more water, but still not nearly enough. It was not planned to be replaced, but guess what? Now it is. It took us a little bit longer because it was a more complex structure, 31 days to get the plans distributed to the contractors, but by that point, all the volume estimates and everything were done. And still, even at that, the roadway was open again by November 15th, just like the previous project. And another picture of what this looks like. There's the double cell cover, obviously not reusable, got to do something different. So what was our process? We had, as I mentioned, existing aerial LiDAR and ortho imagery. So we had the before picture, and we knew what it would take to bring things back to where they were. Immediately after the event, obviously we couldn't be right out there with water rushing around our waists, but as soon as possible, within a few days, we had surveyors out there with terrestrial LiDAR. By doing it that way, we were able to just capture the whole site at once, bear that data back to the office, and start working up the mapping for the area. So we didn't have to go back out into the field unless absolutely necessary. And the whole thing was 4 months from the flood until the time the construction was completed and everybody was back out there. So here's a few pictures of the design products. The elevation, in this particular case, you can see that the culvert was replaced with a bridge span. The little box down there within the picture is where the culvert used to be, and all the cross-hatched area is now to be clean fill. The image below shows where the washout was, so you can see it was like a 25-foot deep washout of where the creek had taken out the roadway and the surrounding area. Here's just a few of the other mapping products we created from that. Obviously, very rough area after it has been washed out. The lower left is actually a colorized point cloud that we created from the new LiDAR imagery. The last project is probably familiar to a lot of people, and that is the US 34 Big Thompson Canyon project. This is the road, the primary road to Estes Park and Rocky Mountain National Park in summertime. And guess what? Just like the previous project, this sure enough happened in the summertime. So this was a total of an 18-mile long project. In 2013, flooding washed out 12 miles of the embankment. We were contracted to do several things on the mapping side, provide mapping about the before situation, mapping of the damage of the repair of the repaired roadway, and then of the final roadway after reconstruction to create an as-built. Our River Engineering Division also did the hydraulics for the redesign and the rebuild. This is a great quote, and it really talks about the challenges of working in a narrow canyon like this. The original plan was to reconstruct the roadway identical to the original, but the assistant project director put it very well, which is, usually you put the roadway where you want, and you make the river do what you want it to do, so the roadway can be where we want it to be. In this particular case, the river is going to have its way, and you need to take that into account and design the roadway appropriately to avoid the river destroying what it is you've done. Fortunately, just like the previous two, we were already involved in an aerial mapping project, in this case for Larimer County. And in this case, it was very recent, literally the month before the flood, we had collected aerial LiDAR for the area of the canyon. So we were able to use that data to get a very clear and very accurate picture of what was in place before the flood event. The CDOT also asked us to go back in time to recreate the situation back since the previous flood, which was in 1976, and to, over a period of time, show the changes at the bank, just so they could see the operation of the natural processes on the canyon as well. So we digitized the bank lines over a series of years to show that. And then we created profiles from the LiDAR that we had done right before the flood itself. So just like the previous two projects as well, there were a series of acquisitions. And these images, I think, is very interesting, kind of shows you the extensiveness of the damage. So we had our existing data. We had LiDAR then that we flew in the fall after the event, once things had calmed down slightly. We determined that photogrammetry alone would not handle the modeling we needed in this steep canyon, so we did high density LiDAR as well. We did photogrammetry the following summer to show the post-emergency repairs, and then again in 2017 LiDAR once more to do an as-built and to get the new floodplain boundaries. So after the flooding, we did the post-flood state to show what had been damaged and what needed to be done. Our hydraulic engineering team, this was a very complex project, obviously a lot of obstacles in the river. They used ArcView Model Builder for semi-automated scour calculations, very challenging, high velocities. The flood was actually throwing boulders around the canyon. And then we created our as-builts using the LiDAR. The primary goal was to create new floodplain boundaries because the design was to have one lane passable during a 100-year flood event. So seeing where those 100-year floodplain boundaries were allowed us to verify that that design goal was met. Of course, at the same time, there were other floods going on in the same area. It didn't stop at the canyon. The Poudre River, the South Platte River in Weld County also flooded. We collected additional imagery in the area, and our engineering people used those images to support a number of river engineering projects at the same time. I will say that I admire whoever designed that wastewater project on the left-hand side, that it remained above the floodwaters. That was fairly impressive to me. So in summary, having an existing mapping program in place makes this much, much, much easier. We know what it looked like before. It allows us to see and quantify the event results. In other words, for example, in the Big Thompson Canyon, we were able to see specifically what a 100-year flood event did because we had the before picture, we had the after picture. The difference is the results of the 100-year flood event. We were able to do more work in the office because we were able to bear that data back there and do all of our work, minimize any on-site timing, any on-site time that we spent there. More accurate construction bidding, especially if you're recreating what you had before. You know what was there, you know what's gone. The difference is what the contractor needs to do. And finally, assessing alternatives is easier because you can say, okay, here's the new floodplains. If we recreate it the way it was, are we still going to have a problem, or do we need to do something different? All in all, the idea of having an ongoing regional mapping program pays off in spades when it comes to a natural disaster. Thank you very much for your time, and we'll be glad to take any questions you may have. Thank you.